Okay, so now we're going to talk about our last topic, our last lesson in this topic, which is linear inequalities. So linear inequalities are very similar to linear equations. The only difference is that instead of an equal sign, there's a less than or greater than sign instead of an equal sign. So as a reminder, a linear equation, a line is y equals mx plus b. So a linear inequality just looks like y is greater than or less than or, equal to whatever it is, mx plus b. Okay. So that's what we'll be looking at. So let's take a look at this linear inequality graph right here. Okay. So you'll notice some things in this graph. It's lines, but it looks a little bit different, right? We have, a dashed line, right? One of these is dashed and one of these is solid. So that's interesting. Another thing too, that there's shading on the graph, right? There's shading right here below this line, and there's shading right here above this line, and they overlap right here. So when we're talking about graphing linear inequalities and the solution to linear inequalities, the solution is the entire shaded region that overlaps, okay? The entire shaded region that overlaps. So where it's just green at the top there is not the solution, where it's just blue at the bottom is not solution, but where it's overlapping is the solution. So we're going to do two things here with this graph. We're going to write the inequalities for each line, and then we're going to take a look and see if these points down here in this table are solutions to our inequality. So I'm going to zoom in a little bit. That's right. All right, so I'm going to have one that's going to be green, so I'll write it in green. So let's look at our green line. So when we're looking at a line and trying to figure out what the formula is, we need to look at the slope and the y-intercept, okay? So our y-intercept here for this green one, I see it is right there, at -3, so -3. Our slope, how we find our slope is we find 2 points that are on our line. So I see one right there at -2, 1. And then I see another one right here at -1, -1. So to get from -2, 1 to -1, -1, I go down 1, 2 over 1. So that means my slope is -2 over 1, or just -2. 2. So now I can put that into my y formula. We still don't know. We don't know if it's going to be greater than or less than, but we do know it's going to be -2x minus 3 over there. Now, how we determine if it's going to be a greater than sign or a less than sign is we look at the shading, okay? We look at where the shading is, where this green stuff is. Is it going above the line, above where our y-intercept is, or below where our y-intercept is? So our green shading is here above our y-intercept. So that means that our y is greater than, because our y, it's shaded above our y-intercept, where our y's are getting bigger. So we have that. Now we have to look for one more thing when determining if it's going to be either a greater than sign or greater than or equal to sign. If our line is a solid line, right? If it's a solid line, then it's greater than or equal to. If it's a dashed line, then if it's a solid line, okay, if it's a solid line, we use the inequality with the line underneath. If it's a dashed line, we use the inequality without the line underneath. So it's not or equal to. So looking at the green line, is this a dashed line or a solid line? This green one is a solid line. So solid means we have the line underneath. So it's going to be y is greater than or equal to -2x minus 3 for our green line. Okay, now let's take a look at our blue one. Erase this stuff here so we have some room to work. All right, so blue line. Okay, so for my blue line, my M, well, first my B, my slope, or I'm sorry, my y-intercept is right here at 1. My B is 1, going to be 1, it's a positive 1. And now 2 points on my line. Let's see, I have one there at 0, 1, and I have another one here at -2, -2. So let's see. To get from -2 to 0, 1, I go up 1, 2, 3 over 1, 2. So that means my slope is going to be up 3 over 2. Okay, 3 over 2. So now I'm ready to put this into my form, my y, and then mx plus b. So y something, we don't know yet, 3 over 2x plus 1. Now, is this going to be greater than or less? Well, let me erase some of this stuff so we can kind of see, graph a little bit more. Okay, so are we shading above? Is the blue shading above or below our y-intercept? Is it where our where our y numbers are getting bigger or smaller? It's below. It's right here. It's where our y's are getting smaller. So that means it's going to be less than, and it's also it's a dotted line. It's a dotted line, dash line. So it's going to not have the line underneath. It's not or equal to. It's just y is less than because we're shading underneath the y-intercept where the y's get smaller. So these are our two inequalities for this graph right here. Y is greater than or equal to -2x minus 3, and y is less than 3 over 2x plus 1. And then our solution is all of that shaded area right here. I hope you guys can see that right here. Is that shaded area? I hope you guys can see my pen when I'm doing that. So now we're going to take a look at these points and see if they are within the overlapping shaded regions, right? So let's take a look. I'll change my pen color to, we'll do purple. Okay. So 0, 0, where's my point 0, 0? Right here. Is that within the region that they overlap? It is, right? This whole thing is where they overlap, all that. So that is within that region, that boundary. So 0, 0 is part of our solution. Okay, it is one of our solutions. What about the point 3, 1? So I'm going to go over to 1, 2, 3, up 1, right there. That looks like it's within that shaded, right? Because again, this whole thing is that region. That's within there. So this will also be, yes, one of our solutions. All right, now let's take a look at the point -2, -2. All right, so -2, -2 right here. Is this part of our solution? Is that within our boundaries? Is that where the overlapping, the shaded region is? No, it's not even in the shaded region. So no. What about the point -2, 1? -2, 1. Nope. Also not even in that shaded region. So also no. And then what about -1, -3 down here? Nope. That's in the blue one, but not the overlapping. So no. And then the point 1, 2 is right here. Is that within it? Yes, it is. Okay. Now, what about the point, we're going to do a bonus one. What about the point 0, 1? 0, 1 right here, right there. That's on that line, right? So this one's a little bit tricky. When you have a point, if they ask you about a point that's on the line, if it's on the line, it's going to depend, if it's part of the solution or not will depend on if it's a solid line or a dashed line. If it's a dashed line, the answer is no. Oh my goodness, this is so bad to write with. No. If it's a solid line, then the answer is yes. Because the solid line means greater than or equal to, whereas a dashed line means only greater than or less than, whatever the sign is. But it's not actually including the numbers, the y. So it's not actually including that number, the one right there on that line. So if the point is on a dashed line, then it's not included in our solution. If it's on a solid line, like this one, it would be included. But if it's on a dashed line, like this one, then it is not included. Okay, so let's look at another example like this one. All right, so again, we're going to write our inequalities. So let's start with our blue one. So our y-intercept is at -2, so our b equals -2. Our slope is what we want to find next. So that's 1 point. Where's another point? I found one right here. So to get there, I go up 1 over 1, 2, 3. So then our slope is going to be up 1 over 3. So 1 over 3. Okay. So now I put this into my, okay, well now before I start writing, let's take a look. Are we going to have a greater than or a less than? Well, let's see. The shading goes up, goes above where our y's get bigger, right? So it's going to be a y is greater than. Is it going to be or equal to or no? Well, it's a dotted line, dashed line, so no, it's not or equal to, it's just y is greater than. So now we use our slope, our m and our b, so 1 over 3x minus 2. Okay, erase that. Just the other stuff. So we have our formula for one of our inequalities. Now let's do the other one. So our y-intercept here with our green one is at 1. So our b is going to be 1. And our m, let's find another point on our graph where it intersects. I see one right here. I might have missed one, but we'll see. Okay, so to get from this point to this point, we go down 1, 2, 3, 4 over 1, 2, 3. So our slope is going to be down -4 over 3. So it equals -4 over 3. So now let's take a look. What our inequality sign is going to be. When we shade, are we shading down or up? We're shading below where our y's get smaller. So it's going to be y is less than. And it's a solid line. So that means it's going to be or equal to. We're going to have a line underneath our inequality. And now we use our m and our b. So -4 over 3x plus 1. And again, we just plug that into the equation y is greater than or less than mx plus b. So that's where these equations come from. When we take our m and our b and plug it into there, we end up here with this. Okay. So that's how we find our inequalities. We've done that. Now let's check our points, see if they are solutions or not. Okay, we'll do it again in orange, or not orange, purple. All right, 0, 0 right here. That's within, again, this is the overlapping region right here, because down here is just green, down here, or up here is just blue. Over here is where we have both. Okay. So 0, 0 is in there, is in that overlapping region, so yes. What about the point 3, 1? Let's go to 3 up to 1. Nope, that's in the blue, but not the green. So nope. Oh my God, no. Okay, next one is -2, -2. So right here, that is within that shaded region. So yes, I'm just gonna write a y. I'm not even gonna try writing a whole word anymore. Next one is 0, -2. That's right there on the line. On the line, once again, if it's on the line, it's a little tricky because if it's a dashed line, it depends on if the line is solid or dashed. If it's a dashed line, it's not. If it's a solid line, it is part of the solution. So 0, -2, that's on a dashed line. So that is not part of our solution. So now what about -1, -3? Let's take a look at that. -1, -3 down here. Nope, that's only in the green, so not that. And then lastly, 0, 1 right here. So again, that one's on a line, but this time the line is solid, so it is one of our solutions. It's not a dashed line. It is a solid line, so it is part of our solution. Okay, so that is how we look at a graph and see if identify if the points are part of the solution or not. Now we're going to talk about how to find out if points are part of a solution if there is not a graph and they just give us equations. So all we do here is plug our x's and y's in. So these numbers here, this is all x, comma, y, okay? All these numbers, all these points, these are points on a graph, x, y, all right? So to check and see if any of these points, or if these points are part of the solution to this inequality, if we graphed all of these and we're looking at the overlapping region, the way to find out if they are part of the solution is by plugging them in to each equation. If it works and it checks out for each equation, then it is part of the solution. But if it doesn't check out for even one of them, then it's not part of the solution. Okay, so taking a look at our first one, -5, 3. Okay, -5, 3. Let's plug that in to our first equation. Y is greater than or equal to x minus 2. All right, so again, our -5, our x is -5 and our y is 3. So if y is 3, then 3 is greater than or equal to, and our x is -5, -5 minus 2. Okay, so all right, so now -5 minus 2 will give us -7. So 3 is greater than or equal to -7. Does that check out? Yeah. So, all right, it works for that first equation. That's good. But it needs to work for all three. So let's try the second one. So that was the first equation. The second equation is x plus y is less than or equal to 4. Okay. So again, if our x is -5, -5, our y is 3 plus 3 is less than or equal to 4. -5 plus 3 will give us -2 is less than or equal to 4. Well, that checks out too. That's a true statement. So we know that that's correct. That works. Okay. So now let's try the very last one. This one is just y is greater than -2. So we just take our our y and plug that in. Is 3 greater than -2? 3 is greater than -2. Is that true? That's true. So that checks out. So then yes, this point would be a solution for our system of inequalities here. Because when we plug in x and y to each of the equations over here, 1, 2, 3, we get true statements. So that first point that we did, -5, 3, would be a solution. Okay, so now let's look at 3, -3. So 3, -3 is our x, y. So again, I'm just going to plug them in. So y is greater than or equal to x minus 2. -3 is greater than or equal to 3 minus 2. Okay, so 3 minus 2 will give us 1. -3 is greater than or equal to 1. Is that true? Nope. So we know that we can stop right here. We don't have to do anything else. We know that that's not going to be a point on our graph because it doesn't work for our first equation or our first inequality. It doesn't. This is not a true statement. So it does not work, and it's not a solution. All right, so next, let's look at 0, 0, 0, 0. For the point y, or I'm sorry, the equation y is greater than or equal to x minus 2. 0 is greater than or equal to 0 minus 2. 0 minus 2 will give us -2. Is 0 greater than or equal to -2? Yes. So that checks out. Okay, so now let's try the next one. X plus y equals 4. I'm sorry, not x. X plus y is less than or equal to 4. So 0, I'm sorry, x plus y. So 0 plus 0 is less than or equal to 4. 0 plus 0 is 0, 0 less than or equal to 4. Is that true? Yes. So then that statement checks out. So that's supposed to be a y, my bad. So that, it works for that one as well, the second equation, but we still have to make sure it works for the last equation. So y is greater than -2. Our y is 0. Is 0 greater than -2? Yes, so it checks out. So that is part of our solution. So now let's look at the point 2, 3. 2, 3. Y is greater than or equal to x minus 2. 3 is greater than or equal to 2 minus 2. 3 is greater than or equal to 0. Where 3 is greater than 0, so it checks out. Next, we have x plus y is less than or equal to 4. 2 plus 3 is less than or equal to 4. 5 is less than or equal to 4. Is that true? No, 5 is not less than 4. So that is not going to be on our graph. All right, next point is -3, -2. Now, y is greater than or equal to x minus 2. So we have -2 is greater than or equal to -3 minus 2. -2 is greater than or equal to -5. That is true. -2 is greater than -5, so that checks out for that one. Gotta check them all though. It makes you almost wish it doesn't work for the first one, just so you can be done with it, right? So x plus y is less than or equal to 4. So then -3 plus -2, so -3 minus 2 is less than or equal to 4. -3 minus 2 will give us -5 is less than or equal to 4. That is true, so that checks out. So now we just got to check the very last one, where it's y is greater than -2. And -2 is greater than -2. Well, is that true? That's actually not true. No, because it doesn't have the or equal to symbol. -2 is not greater than -2. It's equal to. So that does not work. So therefore, that is not a solution. If it says -2 is greater than -2, or any number is greater than itself, that is not true. All right, and then lastly, -1, 3. Okay. I'm just going to plug them in. So 3 is greater than or equal to -1 minus 2. -1 minus 2 will give us -3. 3 is greater than -3. So that checks out for that one. And then we've got x plus y. So -1 plus 3 is less than or equal to 4. -1 plus 3 will give us 2. Is less than or equal to 4. That's true. So the second equation or inequality checks out. And lastly, y is greater than -2. Well, 3 is greater than -2. That checks out, so that's true. So this is also a solution here. So that's how we find out if the points that we're given are part of a solution of linear inequalities. We just plug them in and make sure that they work for all of the inequalities they give us. Okay. So now, lastly, we're going to talk about how to actually graph these linear inequalities. Okay. So we've done it in reverse, right? We looked at a graph and said what the equation was. So now we're going to look at an equation and make it into a graph. So, all right. So first of all, I'm going to distinguish which one's going to be green, which one's going to be blue. So I'm going to say that this one will be my green one, and this one will be my blue one. Okay. So start with green. And okay, so first of all, am I going to have a dotted line or a solid line? I'm going to have a solid line because it has that line underneath the inequality. So I'm going to have a solid line. So I start with my B, which in this inequality is 2 for a green one. It's positive 2. That's our y-intercept. And then my slope, right? So when I don't have a number in front of x, it's an invisible 1. So my slope is just 1 or 1 over 1. So from here, I'm going to go up 1 over 1, another point there, up 1 over 1, another one there, another one there. And then I'll also go in the other direction, down 1 to the left 1, down 1 to the left 1. Keep going. And then I'm going to draw my line. And again, it's a solid line because its y is less than or equal to. Okay. So now we do our shading. Okay, now we do our shading. And this says y is less than x plus 2. So we're going to shade below our line. So where our y's get smaller, where our y's get less than 2. So that's going to be down here. Okay. This is our shaded region down here for our green. Okay. So now we'll take a look at our blue line and graph that. So this will start at our y-intercept of -1. And then our slope is -2. So that means I go down 1, 2 over 1. Down 1, 2 over 1. And then I'm going to go up and I'm going to reverse it too. I'm going to go up 1, 2 over 1. Up 1, 2 over 1. 1, 2 over 1. And my line here will be a dashed line because it doesn't have the line underneath the inequality right there. So this time it's going to be a dashed line when we connect our dots. It's going to look like. And then lastly, we do our shading. So this is y is greater than. So we're going to shade where our y's get bigger, get greater. So above the line. Okay. So then we have shading for two colors, right? But we only want the shading for where it overlaps, right? So let me use a different color to show you what we don't want. Like right here where it's only blue and right here where it's only green, we don't want that. So we're going to erase all that shading and only do it where it's overlapping, which was right here. So when you're working in pencil, it's easy to erase. When you're working with this, it's not as easy. But yeah, right here is where they overlapped. So this is our solution to this inequality system, okay, where it's overlapping. And that's how we take the inequality and make it into a line. So we have 2 more of these, I think, and then we're all done. Okay, so once again, highlight one green, one blue. So this one green, this one blue. Okay, so let's do our blue one first. So y is less than 3. So whenever we don't have an x, or whenever it's just y equals a number or x equals a number, we're going to have a straight line. It's going to be with no. So, okay, we're going to have a line going either straight up and down or side to side. Our x's, our x equals will give us up and down, and our y equals gives us side to side. If you don't remember that, one way that I like to remember it is if it tells you x equals, then you go to that point on the graph, or x is, greater than, less than, whatever it says, right? Where x is 2. And then you draw a line in the direction where you won't touch other numbers, right? So if I go side to side, then I'm touching all these numbers here. So I don't want to do that. I want to go up and down where I'm not going to touch any other numbers with my line. And now with y, right, with y, where y is 3, right, which is what our equation says here. if I go up and down, I'm touching all these other numbers. But if I go side to side, then I'm not, and that is what I want. So that is how I will graph this line. So this is y is less than 3. So it's going to be a straight line side to side at 3, but we want to pay attention if it's going to be a dotted line or a solid line, right? Since it's y is less than without the line underneath, we're going to use a dotted line. So right here, dotted line. That's right at 3. Can we put endpoints on it? Yeah. Let's make it look like an arrow too. Oh, not that one. The other one. This is fun. Okay. So now we have our y is less than 3 line, but we need to actually shade it too now, right? So less than 3 means we go below where our y's get smaller. So that's going to be down here. So all down here is blue, this entire thing, all of it. Okay. Now let's do our green one, which we're going to have a solid line because it has the line underneath. So we started our y-intercept of 1, and then our slope is -2. So we're going to go down 1, 2 over 1, down 1, 2 over 1, 1, 2 over 1. So right there, and then we'll do the opposite of 1, 2 over 1, 1, 2 over 1. So now we will do our solid line. No, let's make sure it's going to be solid. Here. Okay. And then we do our shading, right? Not quite done. We're almost done, but not quite. Gotta do our shading. Y is greater than, so we're going to shade above the line where our y's get bigger, which is going to be over here. Like that. But once again, we don't want all the shading. We only want the overlapping part, which is this part right here. Okay. This part over here is only blue. This is only green. This is nothing. So we want to just keep this part here. So again, I'm going to erase all my shading and only keep where it's overlapping. Reshade. Again, when you're using a pencil, it'll be a lot easier to, you know, just to erase where you don't need the shading. But yeah. So there we go. So that's our final answer for that one. That's what that graph would look like. All right, and then lastly, this one. All right, so again, we'll do our color coding. This one's green. This one's blue. So let's start with our, let's see which one, we'll do blue. All right, so we start with our y-intercept at 3, +3. Our slope is -1 over 2, so down 1 over 2, down 1 over 2. The opposite direction, so up 1 over 2, up 1 over 2. And then this is going to be a dashed line because it doesn't have the line underneath. It's not or equal to, so it's a dashed line. It's gonna look like that. And we are going to shade above it because it says y is greater than, so we're going to shade up here. Then we have y is less than 2x, or what, I'm sorry, less than or equal to 2x. So we're going to have a solid line. I'm just changing my settings real quick before I start grabbing my points. So when we don't have a b, when we don't have a plus or minus a number at the end there, it's just 0. Our y-intercept is going to be 0. So from 0, my slope is 2, +2. So up 2 over 1, up 2 over 1. We'll do down 2 over 1, do the opposite way, down 2 over 1. All right, so now we connect them, draw our line. It's pretty close. There we go, that's a little better. All right, now we just have to shade. So I'm going to shade in green, and it says less than. I'm going to shade below my line. Okay, so all this. So once again, I do only want to keep the overlapping part, which is this part up here. All that overlapping part. So we erase and we keep that. That green line should be a little bit longer. Didn't realize it had stopped right there before, but yeah, it keeps on going. Oh. So that is our shading for that, and we're done. That's it. So I hope this helped. I hope you learned something. Get ready, because we're almost there. It's almost test time. All right. Enjoy the rest of your night, you guys.